Hello, everyone. Time to get started. I'm Ryan Wright. I'm the CTO at ThatDot. And today we're going to be talking about streaming entity resolution for Kafka with an open source tool called Quine. If you've tried to adopt data streaming into existing enterprise pipelines, a lot of the big challenge is that some point in your data analysis, you have to do something deeper. You have to look at the data, you have to look over more data, and that deep analysis usually has to sit at the end of the data pipeline. Sitting at the end means you have the opportunity to collect data, store it, batch it up, and then you can do that deep analysis on a big batch, but now it's at the end and it's in a batch. So all the benefits of the streaming real-time data that you might have implemented upstream don't apply to anything that needs to use the results coming out of that batch process. So what we're going to talk about today is shifting that left. Taking that deep analysis that usually has to wait until the end of a data pipeline and actually moving that into the middle, anywhere in the middle of a data pipeline. So do that analysis in the data stream by taking high volume data in, forming it into a graph, what we call a streaming graph, then taking the results of that, streaming them out downstream. Quine is an open source tool meant for exactly this. So putting a graph in the middle of your data pipeline gives you that opportunity to do that deep analysis that would normally have to wait until later when you aggregate lots of batch results. But you may say, but graphs are slow. We've had graphs for a long time. They're too slow. You can't put them in a data pipeline. And yeah, that's true. Graph databases are slow. We've had graph databases for decades. They're cool, they do really interesting things, they're powerful for what they are used for, but they tend to be for kind of toy projects, small scale sorts of things. And they tend to be too slow to put into a data pipeline. So no self-respecting architect is gonna take a graph database and put it in the middle of their data pipeline. Quine represents a whole new architecture built from the ground up so that you can do exactly that. It's event-driven, it's stateful, it merges old historical data from days, months, years in the past with whatever's happening right now, and it can scale. It can scale to handle millions of events per second. It can remain resilient when deployed across a cluster, even in the presence of all kinds of failure scenarios like you see here. If you'd like to know more and get really into the technical details, there's a short link down at the bottom that'll take you into a more in-depth discussion of that. But this is coming from a real customer use case of ours who had to consume 1 million events per second, monitor the graph that was created in a data pipeline from that data volume, and then stream those results out for the patterns that they're looking for. So let's take one use case and just look at what it looks like in practice. Streaming entity resolution. Entity resolution is a good example case of something that would be great to do in the stream, but usually kind of sits near the end. Because usually you have to collect lots of context, put those pieces together, and get to the point where you've got enough that you can resolve it in a batch. But if we could move this upstream, then knowing resolved entities can really simplify all the downstream systems. So let's take entity resolution as an example of this deep analysis that we push up earlier in the stream. Entity resolution is the problem of when you have lots of references to something that should be one object, one entity, but it's known by many names or many identifiers. So maybe one person uses lots of email addresses, so those email addresses need to be resolved to turn into the entity. Well, in this case, our goal is to resolve those in the stream in real time and do it fast enough so that we have a continuous stream of just resolved entities coming out. Those resolved entities give us a new stream where we have our original data, but it's always resolved. And as I've been hinting, we're going to use Quine, the open source application here, to do it by building a graph in the middle of a stream, performing that entity resolution based on some rules that we specify, and then streaming those results out. Here's an example of what a data record would look like. So from public data sets, public court filings and things, we often walk away with lots of data that is kind of messy. So address information like this, you can run it through an open source tool like libpostal, and then it'll parse it out and kind of help you with that. But it's still ambiguous. And the addressee and the other names go by lots of different names. And so it's still messy, still needs to be cleaned up a bit. What we really want is we want this payload, but we want to add in another field in there that tells us, how does this resolve? How does this one address as written here resolve to specifically one physical place? Resolving to that one physical place is the entity resolution problem for addresses. Let me show you how this works. So I'm going to start up an application from Quine. This is just a version I've downloaded from quine.io. And I'm going to run what we call a recipe to feed it entities. It's that address data like we saw just a moment ago. We've got it starting up and ingesting. You can see that bottom line we're counting as data's ingesting. In this case, it's coming from a local file, but it could easily be Kafka or any streaming source of data. And we've got standing queries that are doing the work internal, and more on that in a moment. But let's look at the data and see what it looks like. Here's a record. If I right-click around that record, I've got a graph that I can play with, and we've got some properties on that graph, or on that node in a graph. And it's just the JSON objects like you'd expect, just the address information as parsed from libpostal. But if I poke around, I can see that this thing is actually connected. Here's the unresolved entity that was mentioned in that original record. On ingest, we pulled that unresolved entity out and created a separate node for it. And this is actually doing kind of the very first phase, let's call it level 0 of entity resolution, because if I poke around a little bit more, all of these records refer to that same entity. So that capital 1, NA, Co, Beckett, Lee, LLP, that's one way to refer to the entity being referred by all these different records. Let's step back a step. On that entity, the way that we know all those records are related is we can go poke around and see the actual subgraph that's built from the incoming record. We get to take the data that's coming off of one record and pull out some of the fields and create graph structure with it. So that one entity, that one data record, referred to this address in the state of Pennsylvania, in the city of Malvern, at that postcode. And we can break apart those pieces into a graph structure. The reason we want to do that is because in a graph structure, we get the opportunity to intersect it with other records. So we could go poke around the city of Malvern and see all these other entities that show up in our data set for that city. Or we could go poke around the state of Pennsylvania and all these entities in the state of Pennsylvania. So we're already doing kind of the first level 0 of entity resolution just by expressing what is coming in by name and intersecting its features with other features in the graph. That's how we build the graph. That gives us the opportunity to find commonalities in our records. But behind the scenes, we also have a standing query that's running. That standing query is watching for the pattern that tells us how to resolve entities. And it lets me answer questions like, what else is this entity known as? Here's a list. These are all aliases that have received communication at that same address. Another way to view the same information is if I want to see it in the graph, let's go query for resolved entities. Each of these little purple dotted lines takes me to a resolved entity, built while the data is streaming in, watching for patterns as the graph is being built, and then drawing these connections based on their graph structure. The reason we can draw these dotted lines, which don't actually exist in the data, is because they're all connected by this canonical entity. This is our resolved entity. This is the one thing. Built in the graph while it streams in, that canonical entity is how we pull all these pieces together just from a standing query running in the background. Now, not only is this building into a graph, but I promised you this was streaming. Streaming graphs means data doesn't just come in and stay there, it also streams out. So on the back side, what we haven't seen yet, and I'm going to actually shut this down and rerun it so that we can watch it happen live. If we re-ingest that same data, just clear it out, start fresh, re-ingest it again, data's coming through, but it's streaming out the results of our entity resolution into this file. This could be publishing into Kafka. Right now, it's writing locally. This is a stream of all the entity resolved records. As a record comes in, it gets connected into the canonical records that let us resolve the entity, and then it streams out because we detect that new pattern. If I slow this down a little bit, we can look at any one record and see, sure, here's a whole bunch of it. This has the information we want, but it's down here at the bottom. That resolved field, that's what we were looking for initially. So that comes from the entity resolution process in the streaming graph. So this is an example of taking a deep problem that's usually reserved till later and doing it live in the stream. I mentioned standing queries. This is what it looks like. In particular, on the left-hand side where it's highlighted, the pattern we're looking for is an entity, the E in the middle, that is connected to a post office box and a postcode. That was our simple resolution rule that we used in this case that actually works quite well in practice. Whenever one of those shows up in the data, the shape of the data triggers the right-hand side of this, the output that says, go take this action. So in this case, the action that we're taking is creating an edge and connecting it to the canonical record. So that's entity resolution in a stream, and it goes further than this. In the interest of time, we're somewhat limited in how far in we can dive here, but you don't have to program specific rules to do the entity resolution for you too. We live in the age of AI, and this is an excellent tool for systems like graph neural networks. Being able to use the connected graph structure to automatically learn what should be connected, what entities should be resolved. What that process looks like when using Quine is really just an API call on your stream. So we've got a data stream, in this case coming in from the top. That stream comes into Quine, builds the graph just like we saw before. But I can make one API call to prepare the training data for a graph neural network. That API call needs to walk the graph, needs to follow random edges, needs to build up a pattern and a history of where it has visited. And that history of where it has visited then becomes like sentences that the neural network can go learn and form a model for. And then from that, it can compute similarities, and we put that back into the graph. What that process looks like is basically as simple as coming over here to the APIs. In the graph algorithms section, let's save a random walk. We can give it all kinds of specialized parameters, but in this case, it's really just the timestamp that we need. Let's grab the current milliseconds and give it a timestamp. This pins the graph. Even though it's streaming and it's continually changing, the way Quine works under the hood is it keeps a fully versioned history of everything the graph has ever been. So it can continue to have data streaming and changing and updating, while also holding a version of it static that can be explored and can be turned into training data to train a graph neural network. So in this case, all I do is say, save it to a local file. I can hit go, and it starts generating my walk at this file right here. With that file, now it's being saved on my desktop here, I can then kick off the training process to train a graph neural network. This is a little less fun to look at, but a neural network that is stepping through its iterations to go through and train, to calibrate itself, and to learn, given that data set, what's similar, what's unique, all the important features. That leads to entity resolution that streams back in. That streaming back in then becomes the key piece of the puzzle for doing live, intelligent, AI-assisted entity resolution on a graph in real time. If you'd like to learn more, there's a link to Quine.io. The open source project is there. Recipes gives you things like what we saw here, a little package of configuration, a little demo for lots of different kinds of purposes, even beyond entity resolution, where it can It can be applied in so many different areas, just all with running one single command line. So check out Quine, supported by a company, ThatDot, and the team that works on this kind of stuff and these kind of applications at scale all the time and every day. So if you're interested in learning more, please catch me after the talk or follow any of the links here on this page. Thank you very much.